My dear friends, today in this lecture we are going to discuss the importance of transformer, a very important electrical static device without which we cannot assume the utilization of electrical power in our house. It is so important electrical device that it transmits the electrical power from one place to another place, from one circuit to another circuit, without changing its frequency. Power also remains constant. Now, some few important aspects about the transformer. There is a very large range and variety of transformer. In mobile charger, we are using the transformer which from 220 volt AC to reduces 5 to 9 volt AC, which further converted into 5 volt DC. And while you from the powerhouse, when the 11 kV voltage is generated, then it is transmitted by long distance with the help of 11 by 132 kV transformer. It is a step up transformer, and 132 kV voltage is transmitted for a very long distance transmission, and at the end of receiving end, again we step down the voltage from 132 kV to 33 kV, 33 kV to again 11 kV, and from 11 kV to 440 and 220 kV volt. So in this way, in the transmission and utilization of electrical power, the transformer has a very key role in the transmission. Now, here we will discuss the very two important parts of the transformer, the basic of the transformer, that is core and winding. So we are using silicon steel core in the transformer because silicon steel material has a large property. It improves the magnetic property. It is also called soft magnetic material. It increases the electrical resistance of the material. It increases the permeability of the material. So the maximum flux is produced in the core. It decreases the leakage current of the core. It also reduces the losses, that is called hysteresis loss, is also minimum. So silicon steel material is very suitable for transformer core for all these purposes. Therefore we are using about 93% steel and 7% of the silicon. This composition of the silicon steel material is highly suitable for the transformer core. Now, after core, there is windings. Next important part is winding. There are two types of winding, primary winding and secondary winding. The windings which is connected with the supply is called the primary winding, and the windings which is connected with the load is called the secondary winding. So the two types of winding play a very important role in stepping up and stepping down the voltage during transmission and utilization. In the primary winding, the conductors we use is either silicon or either aluminum or copper. Aluminum or copper conductor is used, wire is used for the windings because copper has very good conductivity and good mechanical strength, and aluminum, its conductivity is half of the copper conductor, but its weight is less and cost is also less. So large transformer we are using the copper conductor, medium and small conductor we are using the aluminum conductor. But there is another important factor, how to insulate the conductor. The insulation of conducting wires is very essential. So we use the varnish copper conductor or varnished aluminum conductor so that the proper insulation of the winding should be maintained. So for any trouble-free function of the transformer, the insulation of the winding material, winding wire is very, very important. Now, mainly there are two types of transformer, a step up and a step down. When the number of turns of the primary is more and number of turns of the secondary is less, this is called a step down transformer. And here the transformation ratio K is less than 1. Value of transformation ratio K is less than 1 when the primary number of turns of the primary is greater than the number of turns of the secondary. So this is called a step down transformer, and in this case the output secondary voltage is always less and primary voltage is high. And the just reverse in case of a step up transformer. The step up transformer, the number of secondary turns is more and number of primary turns is less. In that case, the transformation ratio K is greater than 1. It is greater than 1, then it is a step up transformer. Suppose the number of turns in the primary is 10 and number of turns in the secondary is 100. Then the 10 times the voltage of the secondary will be 10 times of the primary voltage. It will be 10 times a step up. Similarly, if the number of turns of the primary is 100 and number of turns of the secondary is 10, then the step down voltage will be 1/10 of the primary voltage. In this way, the step up and step down function is clear. Now the very important factor, induced voltage. When we supply the AC supply is given in the primary, the current is flowing through the conductors and turns of the coil. One voltage induced here, that is induced voltage, when the flux is set up in the core, alternating flux is set up. As soon as the current is set up in the turn, the alternating flux is set up in the core, and this changing flux is cut by the turns of the coil. This is cut by the change of the turns of the coil. So the voltage is induced as per the Faraday's laws of electromagnetic induction. When there is a change in the flux, so rate of change of flux is the voltage produced. So this is the Faraday's laws of electromagnetic induction, the working principle. On that principle, here one voltage is produced, that is called EP, primary induced voltage. Similarly, here also the flux is changing flux is cut by the secondary turns of the coil. Here also voltage produced induced, that is called secondary induced voltage, ES. So EP and ES is the induced voltage in the primary and induced voltage in the secondary. Totally depends upon the changing flux and number of turns of the coil. It is some different from the supply voltage. There is some little difference between the supply voltage and induced voltage in the primary and induced voltage in the secondary. But in the ideal cases of the transformer, in the ideal cases, V1 is equal to E1, the induced voltage and supply voltage become equals. Now what is VA? The input VA is equal to output VA because power remains constant. So we get a very important ratio, secondary induced voltage and the primary induced voltage, E2 bata E1 or ES bata EP. Number of turns of the secondary N2 or NS divided by number of turns of the primary N1. This is called the transformation ratio. It is the directly proportional induced voltage and number of turns. These are the directly proportional. E2 by E1 or ES by EP is equal to N2 by N1 or NS by NP. This is directly proportional. But current is inversely proportional. Current is I1 by I2 or primary current by secondary current is equal to K. So this is the very important formula relation. It is relation between the induced voltage, number of turns and the currents of the primary and secondary is equal to K. This is the transformation ratio. This formula we use for any problem to be solved related to the transformer. So these are some basics about the transformer. The formula induced voltage E1 or ES, induced voltage E2 or secondary voltage. This is the 4.44 Fn1 phi m is equal to 4.44 Fn1 BMA. Induced voltage E1 and induced voltage E2, 4.44 F and 2 Fm. Fm phi m is the maximum flux, N2 is the number of turns of the secondary, F is the frequency, and 4 is the formula value. So when we take the ratio of secondary induced voltage and primary induced voltage, then it comes E2 by E1 is equal to N2 by N1. Rest all is cancelled out. So we can derive the formula E2 by E1, E2 by N2 by N1 and I1 by I2 is equal to K. So the following sum I want to once more than wait, because the silicon steel core has a high magnetic property, so it is used to produce the maximum flux and the minimum leakage current, minimum losses. Here the conductor, in the primary conductor, either aluminum or copper is used, but copper is high mechanical strength and double conductivity than the aluminum conductor, and it is insulated. So varnished conductor is used for the windings. Primary is connected with the supply and secondary is connected with the load. So this is the most fundamental working principle Faraday's law of electromagnetic induction. There is no moving part in the transformer, so it is called the static device of the static electrical device. So these are the basic fundamentals about the transformer. Thank you very much.